At the end of the last episode, we could do something powerful. Every adjustable weight in our house model had its own sensitivity score, and we knew how to calculate all of them from a single mistake. But look again at the middle of this model. Two boxes. One says space score. The other says context score. Someone still had to invent those two ideas. A person decided that floor area and bedrooms belong together, and that condition and location belong together. That was a guess. What if those ideas are wrong for this housing market? Or worse, what if we do not know what useful ideas to invent at all? Let me put price aside for a moment and ask a different question about the same houses. Is this house well proportioned? Here's what I mean. A large home with many bedrooms. That works. A small home with few bedrooms. That works too. But a large home with only 2 bedrooms feels wasteful. And a small home crammed with 5 bedrooms feels cramped. So of these 4 houses, 2 are well proportioned and 2 are not. The model has both clues sitting right in front of it: floor area and bedroom count. Nothing is hidden. This should be easy. Here is the model we have been using all along. It gives each clue an importance, multiplies, adds them up, and compares the total against a threshold. On this picture, that is exactly the same as drawing one straight line and saying good houses on this side, bad houses on the other. So let us try. Tilt the line, slide it, turn it any way you like. Watch what keeps happening. Every single line puts one of the good houses on the wrong side. And this is not bad luck. Add up the 2 good houses. Area 4.2, bedrooms 7. Now add up the 2 bad houses. Area 4.2, bedrooms 7. They are identical. Any weighted total gives both pairs exactly the same score. So no line, no slope, and no threshold can ever put one pair above the other. This is not a hard problem. For this shape of model, it is an impossible one. So how did people get past this? For a long time, like this, a person stares at the problem until they see what is missing. And here what is missing is agreement. Does the size agree with the bedroom count? So they invent a brand new clue by hand. Take the area and how far it sits from the middle. Take the bedrooms and how far they sit from the middle. Multiply those 2 together. Watch what that does to our 4 houses. Both well-proportioned houses score plus 1.35. Both mismatched houses score minus 1.35. And now, one straight line on this single invented clue separates them perfectly. Problem solved. But look closely at what just happened, because this is the whole episode. A person had to notice that agreement was the thing that mattered. Nobody handed them that idea. In a problem this small, you can guess it. With 100 clues or a problem nobody understands yet, you cannot. And that is exactly the situation we said we wanted to escape. So let us try to escape it. Here is the obvious idea, and it is probably the one you are already thinking. Do not invent the clue. Put something in the middle. Leave it blank, and let the same learning machinery from last episode shape it. 2 meters. Every clue reaches every meter through its own adjustable connection. Nobody tells them what to measure. Now, before I run this, I want you to predict. We now have far more adjustable numbers than before. Do you think that is enough to solve it? Take a guess and hold it. Here is the result. Loss, 0.125. Look familiar? That is exactly the wall we hit before. Identical. And here is why, and it is worth sitting with for a second. Multiply the two layers out. The meters add up the clues. The prediction adds up the meters. But adding up a pile of adding up is still just adding up. The whole thing collapses back into one straight line. Doubling a number and then tripling it is only ever multiplying by 6. You never escape multiplying. Our blank middle bought us nothing at all. So, the middle needs to do something that adding cannot. Here's the smallest change I can think of. What if a meter is allowed to stay out of it? It shows its total, as before. But if that total falls below 0, the meter simply rests and reports nothing. That is the entire change. Why would that help? Because a meter that can stay silent can pay attention to some of the houses and ignore the rest. 2 meters covering different groups can carve a shape that one straight line never could. Let us run it. Loss 0.002. Solved. And look at what the meters became. This one stays awake for everything, carrying the broad trend. This one rests for 3 of the 4 houses and wakes only for the large home with many bedrooms. Nobody named that pattern. No connection was aimed at it. It appeared because it lowered the error. Now, and only now, the names. That blank middle row is a hidden layer. What each meter became sensitive to is a learned feature, or a representation. The resting rule is an activation function, and the whole structure is a neural network. Notice that we did not need a single one of those words to invent it. But be careful how you say it. That meter does not understand space, or size, or family homes. It became sensitive to a pattern in the examples that helps lower prediction error. That is the honest sentence. Before we finish, rebuild the whole idea without using a single one of today's words. Start with the clues you are given. Put some blank quantities in the middle, and let every clue reach every one of them through its own adjustable connection. Give each of those quantities permission to stay silent. Run your examples forward. Measure how wrong you are. Send that mistake backward to every connection, and take one small step. Then repeat. What comes out are internal quantities that nobody designed, shaped only by what lowered the error. Now the honest limits, because there are several. A meter that stays silent for every house learns nothing at all, and simply stays dead. 2 meters that are awake for everything are just 1 meter, twice. Ours were readable only because this model is tiny. In a real network, most units resist any clean description, and it is a mistake to assume every one of them means something tidy. And notice what we did not do. We did not find the true rule of the housing market. We found something that works on the houses we showed it. Now, look at how far the structure travels. Swap our 2 clues for a patient's vital signs, or the words in a sentence, or the pixels in a photograph. Nobody can hand design the right intermediate ideas for those either. The same blank middle, the same mistake traveling backward, the same small step. And it leaves us with one more question. These features were useful on the houses we showed it. How do we know they will work on a house the model has never seen? If this is how you want to learn AI, subscribe and join us. Like the video, so more curious minds can find the series. And tell us in the comments what clicked, what was unclear, and what we should improve. Your feedback will shape the episodes that follow.